About open source feature stores. So specifically, I'm going to spend a lot of time focusing on Feast and Featureform as they're the more common or most common open source feature stores. So the agenda today, we're going to talk about the feature store, open source feature store landscape, talk about some of the histories of some of the projects, the futures, and the structural differences, the architecture overview. We'll go into code, we'll show the UIs, we'll really break down the key differences between the open source feature stores because even though they are in the same category, they are quite different in their architecture and in the way they fit into your stack. At any time, by the way, through this webinar, if you have any questions, feel free to throw in the Q&A. Similarly, if you're on LinkedIn or Twitter and you're following along there, you can just always leave a comment and Marie will be watching those as well and be sharing those questions here. So let's keep going. Let's talk about the landscape. There are really like three open source feature stores. There's Feast, Featureform, and Hopsworks are like the most common that at least I run into. These are some key differences. Licensing, Feast is on Apache, Featureform is on Mozilla, Hopsworks is on AGPL. AGPL is a quite restrictive license. It means that if you are interacting, even just via an API with open source Hopsworks, you pretty much are forced to be open source yourself. So unless it's part of an open source project, it's kind of not really usable in open source state, whereas Feast and Featureform are very much usable in open source state, and there are many production users of both. Stars, nowadays, most of these are relatively similar in terms of popularity. It's a decent metric to try to gauge popularity. Feast is definitely the most popular, but I would say pretty much everyone's more or less in the same, is popular enough at this point where there's no like magnitude difference. Release cycle, Featureform releases monthly. Feast has been kind of all over just because they haven't really had a maintainer. And Hopsworks is open sources on a 2 to 3 month cadence. In terms of maintainers, Feast doesn't really have one. There isn't really a company behind Feast that kind of guarantees Feast's stability and usability. Whereas Featureform and Hopsworks both have companies, well-funded companies behind them that are pushing the products. Similarly, Feast doesn't really have a business model either. It's kind of like an open source project that's been released. It used to be part of a company that had a business model and they spun it out. And as of now, there isn't really anyone behind it. With Featureform's case, we're open core. So our enterprise project expands upon the open source. And then Hopsworks has a hosted and services and more on top of their open source. Finally, the architecture. Feast and Hopsworks, they both have a type of architecture that I would call a literal feature store, which I'll get into. Whereas Featureform has a very different architecture. We call it the virtual feature store. Gartner would call it the logical feature store. So let's talk a bit more about some of the structural differences between the companies, going back from the projects, going back from their history and moving forward. Why this is important is, as many people who use Feast found, if you were using Feast and you were used to there being a maintainer, and then out of nowhere there wasn't one, you're kind of stuck holding the bag. Like you're now using a project which is no longer maintained. It doesn't really have a strong driving force behind it, which can be a huge problem. So I think as people are deciding what open source project to go with, I think it's really critical to think about some of the structural differences between them and deciding on one that's both solves your technical problem, but two that you trust, that will be around, that will maintain, that will remain maintained and more. So with Featureform was built internally at the former company, it was open sourced, and since then there has been a well-funded startup being built behind it. Feast has a very interesting history. It was originally built at Gojek. It was spun out, and then it was kind of ad hocly maintained and owned by Tecton. And then as of recent, it was spun out, and now there isn't really anyone behind it. So I would say Feast has kind of had a much more. It's been jumped between many different organizations. It hasn't really had like a long-term home since its creation. Part of that is the business models. Like most companies, most very popular open source projects have a backing commercial company. That company typically sells some form of either services, a hosted product, etc., on top of the open source product. It's really common. I mean, like Spark has Databricks, Redis has Redis Labs. If you think of pretty much any popular open source project, there's almost always a commercial company behind it. Um, and the reason for that is if you have a open source project which has momentum, typically it's relatively complex. It's not as common if it's a very simple open source project, but typically when you think of like data infrastructure, ML infrastructure, these are relatively complex systems. And due to that, it makes sense that, hey, there's a problem that is solved here, and larger companies especially want some level of support and services to make sure that, hey, like this is running Spark for my entire organization. I need to make sure that it never goes down and that it consistently behaves, and I'm willing to pay for that. For smaller companies, just having a hosted product can make life much easier, rather than having to deploy your own version of Redis, Spark, or Featureform. You can kind of lean on the hosted version of it, which is just an easier way to get started. Feast does not have and has never had a commercialized business model behind it. There hasn't really ever been a company that's like enterprise Feast or kind of services on top of Feast. And it means that there is no one who's financially incentivized to make um, and maintain and manage and continue to grow the product in the same way. The companies that use it have that, but that tends to work with huge projects like Linux. And even in those situations, you have large companies heavily investing in it. You don't really see it much with smaller projects. Now, that's the structural differences. That's just the difference between the projects and the kind of like the companies and around the project. Obviously, there's huge technical differences too. And I want to spend the rest of the time more or less talking about the architectural differences between Feast and Featureform. This is straight from Feast's website. This is how you can think of Feast. We call it a literal feature store because it takes your batch sources, you transform them, and then finally you store your features in Feast and then serve them out of Feast. So Feast solves that kind of, it's a type of database where you put your features into it and you can serve them for both online and offline use cases. Very specifically, Feast does not handle things like feature engineering. It does not really have streaming features. It doesn't really handle even feature sharing, lineage, data quality, drift detection. It doesn't. Feast is where you just store the features after they've been built. It's not really tied to the actual transformation of the feature, the lineage. This is a key difference between Feast and Featureform. This style of just having the transformations being run elsewhere and the lineage living elsewhere and treating the feature rather as a artifact, like a file or table that gets outputted. We call that architecture, that style, literal feature store. It's not uncommon. Feast does it. Obviously, Databricks' feature store does it. SageMaker does it. Vertex does it. So this is a relatively common style. The reason for that is actually most of those products I talked about, like Databricks' feature store, came after Feast. So a lot of them kind of mimicked the API of Feast. And it kind of tracks. Like when you think of a feature store, This, if I just told you, if I just asked you and you didn't know what is a feature store, it would be a totally fair guess to guess, hey, like it's probably a place where features are stored. But we have a very different take. We at Featureform don't think of our features as tables. We think of them as the definition, the logic. So the feature is not just like the outputted artifact, the table that you then store in Featureform, but rather you define the feature as a set of steps, like a DAG, and that is what is stored in Featureform. And Featureform will then orchestrate it as well. So you will be able to understand and see your features rather than just kind of have these tables that are stored in a database, right? You've designated as your feature store. The other benefit here is it is agnostic to the infrastructure. So some feature stores have an approach where they kind of replace Spark or Redis or whatever. Our approach is very different. We take the approach of just orchestrating the transformations on top of Spark and Redis. So you will have the same one, you don't have to replatform your data. So adoption is much easier. Two, you will have the same latency, same throughput, same cost as you would without Featureform. More in depth, you have a declarative API, which you can see at the top here, where your data scientists define their features as a set of steps. So like it could be SQL, it could be PySpark, it could just be straight Python. Those are stored in Featureform. Featureform has a repository for resources. It has a dashboard, which makes it easy to search things, discover things. We have built-in versioning, lineage, groups, tags. There's monitoring for data drift, uptime, governance for access control, SSO, and then orchestration. So it orchestrates these transformations on top of Spark, S3, etc. And then at the same time, similar to any feature store, the whole point of building these features is to serve both for inference and for training. So Featureform, I think, is much more comprehensive in that it kind of helps. It's a framework for the feature lifecycle all the way through, from the raw data to the feature engineering, all the way to the feature serving and training. At the same time, it's an application layer. It's a framework. It's not really like a core piece of infrastructure in the same way that like Spark might be. It's not actually like this heavy thing. It's much more like a framework. Another way to think about it, if you've used something like Terraform, is that Featureform is the name. What I wanted was Terraform for features. So it's a way to declaratively define your features using an API similar to, not that similar to Terraform, but kind of the same design methodology of Terraform. The whole point of a feature store, any feature store, is to solve these five things: facilitating deployment, enhancing collaboration, organizing experimentation, increasing reliability, and preserving compliance. Before I go into these, I want to actually show you how Feast works and how Featureform works in code and also via their UIs. So first, I will show you the code. We'll start with Feast. So with Feast has this idea where you use a source, like a file source, and then you specify which fields of that file are your features. And then you can create a feature service based on that. That's Feast style. So you would build your transformations. You would build this file somehow. It could be via Spark, could be locally in Pandas, but that is out of scope for Feast. Feast is just where you store the features after they've been created. With Featureform, and then, serving, I should also add, very simple. Like you just specify the names of the features, you specify For training, what you would do is you would specify an entity data frame. So you specify like, hey, here's all the things I need features for. It will retrieve that for you. Same for online features. In feature form, it's a bit different. Feature forms has pointers to your infrastructure like Spark and Redis. You have these sources, right? Like the transaction source. They have variants, which are like versions. So these would have been registered within feature form already. Once you register them, the way to build your features is actually through transformations. So in Feast, you would have run this somewhere else. You would have outputted a file, and then you would have imported that file more or less into feature form or into Feast. In feature form, you actually just the feature definition is the transformation. So you would actually register the transformation with feature form. Then feature form would run this for you. And yeah, it would kind of solve the problem for you. So you would define your features as or new data sets as transformations. You specify where they run, you specify the inputs. You're essentially building a DAG. These build resources in feature form that you can then register features on. So that's like a step that doesn't exist in Feast. Where the transformations are separate from Feast's abstraction versus our abstraction. Everything in feature form is you can convert it back and forth from a data frame, which also makes it much easier to work with in whatever style that you work with. So data frames are just cleaner and typically easier to work with. And so the fact that anything in feature form can be turned into a data frame means that most of your data science workflows is more or less the same. The only key difference is that you are kind of adding a bit more metadata when you define the features. Versioning is done automatically. Naming, descriptions, all these things are kind of pulled automatically. So you don't have to yourself document these things. It's just in the code. The code is kind of documenting the features itself. You can specify your features, you can specify your labels. The other thing that feature form has, which is unique, is you register your training set in feature form. Feature form has the idea of a label. With labels, you essentially build the training set and pre-build it. In Feast, you have to generate the training set each time you train. In feature form, you would have built the training set declaratively, and then you can just serve it. Training is the same because in the end, for training, unlike in Feast where you have to build your training set, the training set's already been defined. So you just say, hey, I need fraud simple, and you can retrieve it as a data frame, for example, and train via that. For online serving, you can do something similar. For the other thing that's unique about feature form is these things called on-demand features, where you can even create transformations that run at serving time. So you can see that feature form really has this focus on the feature engineering. The feature engineering is tied into the feature itself. They're not separate concepts where you'll do your feature engineering and then store that feature. The feature engineering and the feature are tied. They're the same thing. They're kind of defined together. So this is the key difference. And one way to visualize that is if I go to, so this is the UI for Feast. If I go to one of my features, like customer features and transaction amount, this is all I get here, right? Like I just get the name. I don't know what transaction amount is. On the other hand, in something like in feature form, I'll just sign in real quick. I'll just do this. In something like feature form, on the other hand, if I go to a feature, like the same one, like I had the average transaction, I can see the throughput, the latency. I can see the source. This is the thing that's unique. I can actually go through the lineage. I can see the transformations. I can preview the data. In fact, I can also, going back to the feature, like look at some of the metrics. So for example, I can look at like the distributions of the features. I can look at different versions of this feature. You kind of get all of this built into the definition versus Feast where you just get hey, there's a column called transaction amount here. That's it. Um, and even the sources, right? Like these are just files. Like you don't get the transformation. I don't get to see the PySpark transformations that ran to build this file. It's not even tied to it in any way. I just know that there's a file that I just kind of copied into Feast, and this is where the file is. It doesn't really give me much to work with. But we believe at Featureform that the feature and the transformations are the same thing. They have to be tied together. That's kind of the unique take, and that's the big differentiation between Feast and Featureform. Now, let's come back to these value props. Facilitating deployment, enhancing collaboration, organizing experimentation, increasing reliability, and preserving compliance. So we'll talk about all these value props, and then I will, now that you know the difference between Feast and Featureform, I'll show you why it looks different. So let's first talk about facilitating deployment. So Feast doesn't handle batch or stream feature engineering. So the hardest part of deployment isn't typically copying a file to your online to something like Redis, right? It's usually rerunning these transformations, having scheduling set up, handling streaming transformations, all that stuff. But that's not something that Feast does. So Feast is facilitating deployment and to the extent that it's giving you a database to output your features to, versus Featureform where we're actually making it simple to define the transformations and we will run them for you in production. Um, so I'm going to come back to the deeper diffs between them. So, when you think of building a feature, you're working in notebooks, you're building transformations, you're kind of iterating to build these feature sets, and then you're finally training. One thing that happens a lot is that you'll have these perfect features in your notebook, but then deploying into production really gets in the way. It's really tough. It can be very hard, especially for things like streaming, but even just for simple batch transformations. Just building something that's production grade is very different from the process of kind of experimentally trying different things and analyzing your data. Production features are just different. There's different concepts. There's like pre-processing features. There's request time transformations. So you have to think about things like latency. You have to think about uptime. You have to think about freshness. Like how fresh is this data? And that is unique. It's different with when you're experimenting and building your transformations for training or just to understand your features. You don't really have to think about freshness. You just grab a data set, you just work with it, typically in batch. You don't think about scheduling, you don't think about updates, you don't really think about latency. Um, you don't think about request time. There's no request time because you're just kind of working with a data set that's more or less static when you're working with it. And getting it production requires just pretty much rewriting these features. Now, there's different approaches to this. In some approaches, data scientists themselves end up writing complex Airflow DAGs, trying to get things in production. The other style I see very often is ML engineers or others taking notebooks and then converting them into production features. Both of these have problems. In one problem, you have data scientists writing complex production data pipelines, which is not something that they are. Data scientists are amazing at coming up with great features, building great models, deploying and managing production grade data pipelines. Some of them can do it, and some of them are very good at it. But I would say an average data scientist is not a exceptional data engineer. They're just different skills. In the same way that an average software engineer is going to not be a great data scientist. They're just very different skills that require very different specializations. Um, Now let's think about Feast versus Featureform here. In Featureform, you're defining these transformations. The same transformation you write in experimentation converts into production. So you're kind of writing them with the annotation, describing what they're going to be like in production, and Featureform will make that happen. So you rather than having to rewrite the features entirely and having to build these complex data pipelines for production that are just separate from your training ones, they're the same. Um, um, let's talk about the next value props, which are enhancing collaboration and organizing experimentation. Feature documentation is a huge problem. Most people don't write them. And the problem here is that with, or I guess the way this is solved in feature form is that we grab the code itself and we grab any documentation that you have in your code and we attach that to the feature. So at the very least, you'll be able to see the transformations that build the feature and you can kind of deduce what it is, even if it's not documented. So the documentation is implicitly there. With Feast, when you have a feature, like I showed you, you don't have the pipeline attached to that feature. So if someone doesn't manually document it and maintain that documentation, because documentation has to change because feature pipelines change, you won't be able to know what it is, which makes collaboration almost impossible. The same thing is true of organizing experimentation. Feature engineering is a very iterative process. Featureform has built-in versioning so that you can, and built-in search and discovery. Feast even mentions in there things that Feast doesn't do, that they don't really do collaboration. It's not kind of a core competency of Feast. So that's another kind of place where Featureform really shines. It's especially important when you deal with much more complex pipelines where you have tables and Snowflake, you have PySpark scripts, you have untitled notebooks, you have other kind of YAML files, scripts being used to copy data where it needs to go. And on top of all of this complex pipelines, there is pretty much no feature documentation. Increasing reliability. Once features are in production, it's not done. Like features change in production. You really need to monitor them, understand what they're doing for things like drift. If you push features in production without drift monitoring, like you're kind of, it's like leaving your house with the oven on. It's just a high risk thing. And when it goes badly, it can really fail catastrophically. And I've seen it before where people's models start misbehaving and it becomes a mad dash to figure out why. If you don't monitor your features, you can't really understand if they've changed from when you trained. You just lose a lot of context that could really help you debug. Feast does not do any feature monitoring. They push it off to other tools. It's kind of on you to try to figure out how to do this. Featureform does it implicitly. And then the final one is preserving compliance, which you can build some set of rules on top of Feast, but because it's not tied to the data transformations themselves, in our case, like lots of the logic is implicit. If we have a table or a file or a directory, whatever, that is highly sensitive, it's PII, we will know that in feature form. We will know that the feature depends on a source, which is PII. So we can kind of deduce and maintain and manage compliance in a much more natural way than having to essentially rewrite your entire rule set in a new product. So these are the core differences between feature form and Feast. There's more, like a more detailed diff that I can get into is deployment. Feature form is deployed on Kubernetes. Feast isn't really deployed. There's no like Feast job that runs. Materialization engine. Feature form has a distributed job that works on triggers to materialize your features. Feast is manual. We're 12 times faster than Feast for serving. We have governance, we have monitoring, we have stream processing, we have versioning, we have lineage. So there are a lot of key differences between Featureform and Feast. In short, Featureform has taken the approach, because of our architecture, to act more like a orchestrator and metadata store versus Feast, which acts more like a database where you store your features. That difference sounds small, sounds nuanced, but when you think of how different that plays out in your infrastructure, it becomes really clear, at least to us and our users and customers, that Featureform is much more comprehensive and solves a problem much more concretely, rather than it's solving the problem you have in a way that actually solves it and isn't just like part of the solution. A lot of the people who use Feast essentially build Featureform on top of Feast to make it work that way. So in review, Featureform is a virtual feature store. We make it possible to define, manage, and deploy your ML features. using a declarative API. You write your own transformation code. We don't have our own like transformation DSL. It's your code, your infrastructure. What we provide on top of that is an application layer that gives you a resource repository, collaboration, monitoring, and governance, while also orchestrating your infrastructure to work like a feature store. It's a framework. It's a way to take your logic, feed it into a framework, write via a framework, and then have that work for both production, training, experimentation on top of your own infrastructure. So we really have taken that methodology that Terraform, having that kind of infrastructure as code, and took it here, where now you have features as code. So that's the key differences. That's all I have for you all today. If you have any questions, feel free to throw them in chat or in Q&A if you're in Zoom, and I'll happily answer them. I'll give it a few minutes for you to add any questions you have. Otherwise, I'll hand it off to you, Marie.
All righty. Thank you guys so much for joining the webinar. I'll be sending you all a little email after this, giving you the recording of this webinar, as well as links to our Slack community and our docs. Other than that, have a good rest of your day.
Thanks, everyone.